Okay, so there are these extra commands that have effectively no channel information. They're good for the entire MIDI system. So these are called system commands, and they have the command bit of all ones, like F something. Right? If you see F something, you know it's a system command. So there are some big ones that are used. For instance, there's F1, which is used in MIDI time code. There's a way of encoding time in MIDI that's very useful for synchronizing like movie frames. And like that's how it's synchronized. It's got an hour frame, minute frame, and a second. And then, you know, if like a movie is 30 frames per second, it'll have a counter that goes from 0 to 29. So it counts frames. That's MIDI time code. I don't really talk about that because I don't find it particularly helpful for a lot of MIDI stuff. But then there are other ones like song position pointer. Like if you've got a song as a definition of music file, you can tell it where to go in that song by using the F2 command. Or similarly, if you've got multiple songs, a sequence of music, you can select from them using F3 command. System command. Okay. The most important one and kind of the most used system command is the system exclusive command. And what that is actually a way of allowing manufacturers to put arbitrary information in there in the MIDI stream. So you have a flag that says begin system exclusive, which is F0. You have the manufacturer ID, which must be registered with the MIDI standard organization. So every company gets manufacturer. And then after that, you have whatever you want. You have random, not random, but proprietary data. And then there's a command that tells you the data is done, that's F7. So system exclusive can be used for any number of things. For instance, sound file dumps that I mentioned before, that would be system exclusive, right? Sound file dump, like if you had a snare sample in a drum machine, you use a system exclusive command, and then you effectively figure out a way of packaging these raw PCM sound samples in that system exclusive. Now, it's funny, the system exclusive was so useful that they decided to come up with standard system exclusive messages. So they came up with an effective system exclusive message, which basically became an extension of the MIDI standard. There are so many things that people were doing in system exclusive. They said, well, there must be other things to be done, so let's standardize it some. So for instance, one useful thing would be this. This is a device query. The system exclusive 7E NN, which is the channel number, and then the message is 0601 that says, what are you? And this is like if you ever played with a GPIB instrument in the lab. They have a similar thing, and most serial port instrument interfaces have the same thing, an IDN command, identity. So this is the MIDI version. Now it didn't come to later because they stuck it in the system exclusive. But now, so if you do this now, you can send a system exclusive message, and you'll get back a value that includes the channel number again, the manufacturer ID, a family code, and then a member code. So within each manufacturer, they can have the manufacturer, the family, and then the member. So there's a way of specifying what the device is. And then within that, they have the revision. So for instance, like Yamaha has a manufacturer ID, and then it'll have its motif family of synthesizers, and then within that, it'll have various numbers. Okay. System exclusive messages can be used program patch settings, which you later use with the patch change. So the patch settings for any synthesizer, the internal storage of that is going to be different for synthesizer to synthesizer. But you can program that using system exclusive. And then you just use the patch change to switch to it. And then it's also, again, very common for dumping files, or as I keep mentioning, samples is a great example, which is incredibly slow. Often it's a system exclusive, often shortened to sysax messages. And they're common. Okay, briefly just talk about sequencing. Sequencing is basically the technique of recording your MIDI onto a device and then playing it back. Nowadays, it's very common to be integrated. But basically, originally, you'd have a standalone sequencer or a personal computer, not necessarily a quote-unquote PC, because very often in the 80s you had here a Macintosh, which was a common solution for doing music stuff. Even now, as it is now, the Mac is very preferred by music players. But also the Atari ST series was very popular for its MIDI ability. And so you can record it to the computer, it could store it. You know, back then computers stored it on disk or possibly even tape. And then it's nice because now you've got these commands stored. If you want to change the key, it's simple software to change the key. Change the tempo, it's again, it's programming a few bytes. Very, very handy. And in the 80s, you know, very advanced almost. You had in and out, and sometimes they'd be set up so that the out would act as a through during recording. So if you had a bunch of sound bites, you'd still hear them playing as you're recording it. The controls are very similar to tape machines. They have, you know, usually there are buttons on the screen. They're like record, play, pause, etc. And nowadays you've got integration on it. So you have a lot of older programs, Cakewalk and etc., which were these old MIDI programs that existed from, if not the late 80s, early 90s, and they did MIDI, and then I believe Cubase was one of these that it was more of a sequencing program, and then when it became practical to do hard disk recording, they added that feature. Well, Pro Tools kind of came later, and they were really a hard disk recording, and they have some sequencing as well, but it's really a hard disk focus. So even though sequencing has been around longer, some programs have more of a focus toward recording as opposed to sequencing.
Is Cubase one that's pretty common for like electronic music now?
Mm-hmm.
I'm trying to remember. There's some programs that are like really common.
Cubase is one. Also, well, Ableton Live. Yeah, that's got a different feel. That's not like a strict hard disk recording. Dan, the guy who was in here a few weeks ago, he's actually really good at Ableton Live, and you can use that for a lot of things. You can just do straight hard disk recording, especially if you've got very a way where you can break down your song instructions, something hierarchical, where you have pattern A for X bars and pattern B for Y bar, and something like that. It's great because you program up those patterns, and then you can put those patterns in. You can also do some cool stuff with it live, where you can hook up a foot controller and you can be kind of looping on the fly. Yeah, so it's really powerful for that, and so it's kind of an interesting program that it balances those two worlds. It's a live performance program as well as a recording program. When you look at like the visual format for how you record MIDI, like the old way, and a lot of it was you often laid out a music stack. That's a pretty straightforward way of doing it. A lot of programs had that. Even older than that was kind of a textual event list where you give it note on commands. You lay out the list, note on, and that would be kludgy, but again, yeah, it worked. It was the 80s. I mean, we weren't spoiled by GUIs. The most common one now is what they call a piano roll format. Yeah, and that's it's named after an old player piano, where you would have effectively rows, and each row would be a note, and then the player piano you'd have a hole in the piece of paper, and that hole would give you the length of the note. Do the same thing on a computer screen, and that's a piano roll. Then you also have a feature in MIDI. When you record it to a computer, you can do quantization. And what that says is that MIDI is pretty much limited by the gradation of pulses per quarter minute. And that's completely variable. You'll see that in the MIDI file, but you can specify that. So that if you have an older computer, you can specify a few pulses per quarter minute, fewer clock ticks, less resolution. And effectively, it's a lower sampling rate, if you will. And then you can speed that up. And if you speed it up,